Everyone, this is Kushal Himani, and today is day 2 of the Arduino Uno course. Let's start. We will be learning about electronic components. We'll be learning 5 of electronic components, and we will be making 2 circuits. Breadboard. Breadboards are put together to make simple circuits that closely relate to the final boards. Building circuits with a breadboard is as simple as sticking wires and components into holes. So breadboard's holes are connected. The connectivity is these lines are connected. All of these 1 to 30, both sides, are connected like this. And these lines are connected like this. These holes are connected via one wire which is found inside the breadboard. Suppose you have a bulb here. So this is a bulb. One stick is connected here and one end is connected here. And now you can use this to connect here and the battery connected here. Plus here and minus here. So this is a simple circuit. Now let's move on. Next component is an LED. These diodes convert the electrical energy into light energy. It produces energy in the form of light in forward bias direction. Now, it has 2 points, anode and cathode. Anode is plus, positive, cathode is minus. If you look into your LED, you'll be able to see this. The smaller one is plus, the larger one is minus. There is one more way to identify it. The positive side has a long wire, the negative side has a short one. This is how to represent it on a paper. Resistance. These resistors deduct some amount of voltage or current flown. So the max value, the minimum value or an LED, like we saw on the previous slide, can use is 220 ohm. The resistance is measured in ohm always. Now, let's take an example. This is the example, right? Now this black is 0, orange is 3, green is 5. So we'll be taking this 10 raised to 5 ohm or this. Now 0, 3, 10 raised to 5. 10 raised to 5 means 1 with 5 zeros. So it is 3, 1 with 5 zeros. So it can be written as 300 k ohm. There is one more example now. Suppose we have blue, violet, yellow. Okay, so this is the resistor. Let's also make it. So suppose you have this. Last part is yellow. Second last, because we have this also. I'll be explaining it later. Second last is yellow. Then it is violet. Then it is blue. Resistance is always measured like this. Okay, so blue is 6, violet is 7, yellow is 10 raised to 4. So if yellow is written here, the number will count as 4, not 10 raised to 4. This is first band, second band, third band, and fourth band. Okay, so it is 67 with 4 zeros. Here it is. So it is 670 K ohm. Now, the fourth band is tolerance. Tolerance is not used that much. So, you will be learning it in college if you are going to do electrical engineering, or in the first year of college if you are doing mechanical. So, this is the first task, LED control. So, this is an LED. You can see that this side is bigger and this side is smaller. Next is a 220 ohm resistor. There it is. This is a jumper cable. And battery. So this LED will be put like this, as we had discussed. Because these lines are connected. Next is a resistor. I had told you that one side of the resistor will be put here and one will be put here. The wires can also, instead of wires in the bulb, we can use a resistor for the LED, because LEDs can't handle that much voltage. And there's one wire connected to the other side, and then supply of battery. Positive will be connected to positive, longer side, and negative will be connected to negative, the shorter side. Here it is. The LED is on now. So you guys may not have all these components. So let's make it on Tinkercad also. So this is Tinkercad, the Google screen. Go to tinkercad.com. If you have already logged in, you will get this dashboard. And if you haven't, you will be getting a home page. And if you have to log in, look at the past live stream. Here it is. We can rename it later if you want. Next is a resistor. First of all, let's just drag it and keep it on the side for now. LED, battery, 9 volt always, and a breadboard. Let's change this to all first of all. Breadboard. So we'll take the larger breadboard. Here it is. I told you that all these are connected and it is divided here. So this side it is connected and this side it is connected. The whole line is not. And the rest is same. Let's take the LED. One side here and one side here. You can see that Tinkercad has also added a longer one and a shorter one. Anode and then cathode. Let's take a resistor. Resistor will be put here. And this can be put here. We'll take one more wire from here to here. You can drag and drop it. Now this is the battery. Let's rotate it. Negative, positive. Start the simulation. The LED is glowing because the resistance is set to 1K. Let's set it to 220 ohm. It will give you an exclamation mark because the current through the LED flowing is 30.9 milliampere, while recommended is 20 milliampere. The lifetime of the LED will be reduced. So it is best to set it as 1K. So it is 1K, right? Now let's see what happens if we make it 1 million. The brightness has reduced. You will not even be able to see it. 1N is nano. So this is milli and the rest are less than milli. K, million and something else. So 1 million is low, K is okay, ohm, it will burst. Current through the LED is 808 milliampere, while absolute maximum is 20 milliampere. So let's stop the simulation. So this will be your first circuit, or as shown in the PPT, task 1. Now let's switch back to the presentation. So this is task 1, which we have already done. And let's move on to task 2. Task 2, we'll be using an LED, resistor. Yeah, task 2. We'll be using a breadboard, 3 LEDs this time, because we are making a parallel circuit here. LED will be put here, like we had done last time. I'm readjusting the camera. Now, we'll be keeping it, putting it like we had discussed in this diagram also. One more. And the last one. You'll have to do some adjustments, but it is mostly simple. Done. It is okay if it does not go fully inside. Okay, because the point where it connects is starting from half length. Here, you can attach it at the corner also and goes to the power supply place. Next one. And rest same for all. So it is the same circuit, but we are using one battery for 3 LEDs. The resistors are also same, 220 ohm, because it looks bright and it doesn't affect a lot, but it affects. So I suggest you use 500K or 1K, 500 ohm or 1K. Now resistors, three resistors, Let's put the resistors now. It is the same for all of the LEDs. There is a way to use one resistor also, but that is not safe, so you will not be learning it. See, this board comes in parts. You can break it, attach more boards, like these points. Now let's add the battery. Positive to positive, negative to negative. It is on now. You are not able, you may not be able to see whether it is yellow or green or red because of the bright light that is coming to the camera. Now let's make the same circuit on Tinkercad. Let's switch to the Tinkercad screen now. Here it is. Create new circuit, like always. 3 resistors. It is good to take the components first so that there is no jumble of components anywhere. Next, we will need a breadboard. Let's take a small one this time. And battery. 9-volt battery. We'll connect it this side now. Unfortunately, in Tinkercad, you can't change the color of the LED. But you can change the color of the wire. So let's set it to orange for now. Add one more. Let's put it a little far from the first one. Let's change this to blue, wire blue, and then the next one will be farther. And let's change it to pink. Here. You don't always have to follow if it is negative or positive or negative. You can attach it directly, even if it is negative or positive. Here it is. There's one more thing left. A jumper wire. Now, preferably, it should work. Start the simulation. There is something wrong here. This is not connected. Yeah. Now they are glowing. You can make it brighter by changing the resistance of each. This is 1K ohm. I'll just change it to 220 ohm. Next one can be 1K, and the last one can be 10K. You'll be able to compare these. If you move them a little closer. Here it is. This is brighter. This is not at all bright. This is bright, and then this is brighter. Let's stop the simulation and let's go back to the PPT screen. So we had discussed this, and this is the end of today. Day 2 of the Arduino course. Please stay tuned for the following days. Thank you and have a nice day. For doubts, if you have any doubts, please write them in the live chat. Thank you, IITT out. As no one has any doubts, I will end the live stream. Thank you and have a nice day.